Hello. We've previously talked with Dr. Peng about the technical advantages of SRv6. Today we're going to explore the value of SRv6 in applications, external voices, and the relationship between IPv6 services and SRv6. 2018 was a key year for accelerating the improvement of SRv6 standards and solutions. Then, at the beginning of 2019, China Telecom Sichuan deployed SRv6 VPN-based video services, the first commercial SRv6 site in the industry.
The technology developed very quickly over those 2 years.
2 years is not a particularly long time. For some countries and regions with underdeveloped infrastructure, their networks have achieved leapfrog development through SRv6 in a very short time frame. Can you tell us why SRv6 deployment is so fast and why SRv6-based service provisioning is so efficient?
Yes, we have a case where SRv6 quickly supported VPN service provisioning. This clearly demonstrates the advantages of SRv6 in deployment. Typically, provisioning VPN services requires multiple departments to collaborate, which places heavy demands on both time and labor resources. But with SRv6, we can implement incremental deployment. For example, SRv6 can first be enabled on network edge devices, so that SRv6 VPN-BE services can be quickly provisioned. Then we can select some key nodes on the network to enable SRv6 and implement loose TE, meeting the traffic engineering requirements of most carriers.
We often talk about the advantages of SRv6 from the perspective of protocols. For example, we say that protocols are simplified and cross-domain deployment is simple. For carriers, however, they may be more concerned about whether SRv6 can bring new service growth and new revenue. What do you think are the benefits of SRv6 for carriers?
I think this point can be analyzed based on the overall IPv6 enhanced technology system. IPv6 Enhanced 1.0 focuses on SRv6, which is an underlying network support technology. In IPv6 Enhanced 2.0, 5G and cloud-oriented services can be supported based on SRv6 to provide many new types of network services, such as network slicing and IFET for performance measurement. Extended further to the terminal side, IPv6 Enhanced 3.0 uses IPv6 packets to carry application-side information into networks, enabling the network side to be more directly aware of the requirements of the application side. This helps provide better and refined network services for diversified applications, further increasing the business value of networks.
From the perspective of services, SRv6 clearly has many advantages. Nevertheless, some customers still have questions about SRv6 deployment. Would you be able to answer some of the typical questions they have?
Of course.
Some customers assume that SRv6 makes IGP deployment much more complex. Will IGP performance be adversely affected?
SRv6 does not increase IGP complexity. SRv6 requires some information to be added to the TLVs of IGP packets in order to advertise SID-related information, but this has little impact on IGP performance. The draft regarding SRv6-related IGP extensions has already been released as an RFC. Viewers can refer to it if they're interested.
Another common concern is that compared to MPLS packets, SRv6 packets result in lower average forwarding efficiency. This reduces the available bandwidth of the transport network and increases required investment in it. Is that right, Dr. Peng?
Yes. When MPLS was introduced to IP networks, people were worried about a corresponding increase in overheads. Yet despite this, MPLS provides the traffic engineering capability as an alternative to the original best effort mode on IP networks, guaranteeing the SLA. This is a qualitative leap for carriers to provide network services. Similarly, SRv6 brings additional overheads due to SRH encapsulation and the SID length. To address this issue, some header compression solutions have been proposed and are being discussed in the IETF. But SRv6 also provides many new functions, such as fast VPN service provisioning, network programmability, and support for new network services, bringing clear and tangible benefits to carrier networks.
And finally, the last question. Does SRv6 deployment require network-wide devices to be upgraded, increasing network investment?
Not really. SRv6 networks support incremental deployment. That is, SRv6 can be initially enabled on network edge nodes only in order to quickly provision SRv6 VPN services. Then, SRv6 can be enabled on selected key network nodes to implement loose TE. Finally, strict TE can be implemented, which means that each node on the SRv6 network supports SRv6. So, one of the main advantages of SRv6 is its ability to support incremental deployment. This is in contrast to MPLS, which requires a network-wide upgrade.
We can consider SRv6 to be a tunneling technology based on IPv6. So some people believe that SRv6 needs to be deployed to carry IPv6 services only when such services are available. Dr. Peng, is this correct?
IPv6 networks are not equivalent to IPv6 services. SRv6 is based on the IPv6 data plane. We can think of it as a train running on IPv6 tracks. Services in the carriages of the train can be IPv4 or IPv6.
So SRv6 can be deployed on networks that only have IPv4 services, right?
Yes. SRv6 enables a network to be programmable. For example, explicit paths can be programmed to better provide the SLA guarantee.
China is currently making significant efforts promoting IPv6 development. Can you tell us what role SRv6 plays in promoting IPv6 development?
We need to consider this from several angles. As I just mentioned, SRv6 is based on IPv6 networks. So, on one hand, to obtain the network programmability offered by SRv6, your network must be IPv6. But based on SRv6 and IPv6, we can have more new types of network services, just like those in the IPv6 Enhanced Technology System. SRv6 can also be deployed on the cloud, meaning that it can be directly supported on the application side. As such, we can deploy IPv6 in end-to-end mode.
Thank you, Dr. Peng, and thank you for watching.